to my channel. So in the last video we have learned about what is electronic affinity. So in this video we're gonna learn about the electronegativity. So let's get started. We can just simply define electronegativity as the tendency of an atom to attract the shared pair of electron towards itself in a molecule is called electronegativity. And actually it's not the property of an isolated atom. It's the property of a bonded atom, that is covalently bonded atom. It's the property of covalently bonded atom. And this electronegativity has no units because it is a relative property of attracting the electrons or the electron pair towards itself in a molecule. And the main factors affecting electronegativity are: electronegativity depends on first one, atomic radius. And this electronegativity is inversely proportional to atomic radius, because if the atomic radius is very large, then it means that the tendency of attracting the electron pairs is less. But if the atomic radius is very small, it means that the attracting tendency is very more, which is the electronegativity is more in the smaller atomic radius elements. And by this we can say that electronegativity also depends on the nuclear charge, because if the nuclear charge is more, then the atomic radius will be less. If the atomic radius will be less, it means that the tendency to attract the electrons towards it is more. That means electronegativity will be more. So by this we can say that electronegativity is directly proportional to effective nuclear charge. And the next factor is oxidation state. This electronegativity is directly proportional to oxidation state. And suppose if we take one example like Fe2 plus has electronegativity of 1.96. But whereas Fe3 plus has the electronegativity of 1.83. Okay, if the oxidation number is very more, then the electronegativity is more. So now actually there are different scales to measure this electronegativity, like Pauling scale, and different types of scales are introduced to calculate this electronegativity. And in the Pauling scale, we'll just calculate this electronegativity like the electronegativity of elements are calculated from values of bond energies. And the formula used to calculate the electronegativity difference in Pauling scale is XA minus XB is equals to 0.208 under root delta. And where XA and XB are electronegativity values of elements A and B respectively. And delta is the experimental bond energy minus theoretical bond energy. That is, it is the polarity, bond polarity of AB bond. Bond polarity means experimental bond energy minus theoretical bond energy. And the highest electronegativity value is for fluorine, which is fluorine electronegativity value is 4. And next one is chlorine and nitrogen, which is 3. Have the electronegativity value as 3. Both of them have the electronegativity value as 3. And remember that the electronegativity concept is not applicable for inert gas elements. And as I said that electronegativity value increases as oxidation state increases, because the attraction for the electron increases if the oxidation number increases. So the electronegativity increases as the oxidation number increases. And we have another scale to measure the electronegativity values, that is Mulliken scale. And according to the Mulliken scale, electronegativity is the average of ionization energy and electronegativity, electronic affinity. And this electronegativity values in Mulliken scale are approximately 2.8 times greater than the Pauling electronegativity values. And Mulliken scale is applicable only to the univalent elements. So actually all the elements electronegativity values are actually introduced by this Pauling scale only, and it's a widely used scale. And after this Mulliken scale, now we'll learn about the variations in groups and periods. So in groups, from top to bottom, electronegativity decreases due to increase in atomic radius and decrease in nuclear charge. So if the nuclear charge decreases, the electronegativity also decreases due to attracting tendency is decreasing. And if we take one example, in 1A group, the order of the electronegativity is Li greater than Na greater than K greater than rubidium greater than cesium. And in the 7th group, that is halogens, fluorine has the greatest electronegativity, next chlorine, next bromine, next iodine. Decreasing order of electronegativity. And in this, chlorine has the highest electronegativity in whole periodic table, that is, as we already discussed, that it has electronegativity value as 4, and chlorine has electronegativity value as 3. And there are also some applications of electronegativity, that is, electronegativity values are used to know the nature of the chemical bond. Like, first point will be like, if electronegativity difference of two elements in a compound, in a molecule or compound, is less than 1.7, then the bond is covalent in nature. And if the electronegativity difference is equal to 1.7, then the bond is 50% ionic and 50% covalent. If the electronegativity difference is more than 1.7, then the bond is ionic in nature. And this is the most important application of electronegativity. And we have already learned how to calculate the electronegativity difference of an element. So by that we can just find the nature of this element in a molecule or a compound of a covalent bond, or the chemical bond. The next application is electronegativity values are useful in writing the formulae of a compound. Like if they give the electronegativity value of an element X, that is 2.1, and element Y as 4, then the formula would be HF, because the electronegativity value of H will be 2.1 and electronegativity value for F will be 4. So by this we can easily find out the formula of a compound, and we can easily find the nature of the element, that is whether it's a metal or non-metal, we can find through the electronegativity values. Thanks for watching this video. Please do like, share, comment and subscribe to my channel, and don't forget to click on the bell icon so that you can get more updates of my new videos. And in the next video we're gonna do some related problems of electronegativity and make the concept more clear. Till then, bye bye.